why we are starting with DSA. Any sort of idea from your past experience anyone wants to share? Anyone who have given interviews and find that out that even for this role they are asking DSA, such kind of things, or if you might have ever thought while you are studying, why I'm using DSA, why I'm studying DSA, such kind of thoughts, has it ever come to you? Go on. I'm sure everyone would have.
I think it's more to do with the basics. I mean, like, so if you understand like and how good you're like at the basic level of coding right now, I think everything is like if you go to the latest versions of any programming language, everything will be like what do you call it's ready made. I mean, so you don't have to like worry about like what is the background behind the how which data structure is working, how I mean you get all the ready-made functions and everything.
Okay.
But if you know how the function actually works, so you're pretty much like I mean you're good with the fundamentals of coding and everything. So I mean to test your like knowledge of coding, because more of the stuff you get in, you can Google stuff, right? I mean, even a piece of coding, Google stuff. So I think the basic, I mean the basic, this one why they ask in interviews, I mean, is because so that people, I mean, they know that you understand what to code. So if you have, suppose you need to code a new function that's maybe not available anywhere, and you need to build something from scratch. So if you know data structures, people will know that you're like pretty much hands-on on coding and everything.
Okay. How much frequently you'll have to build something from scratch? Very less.
Very less, yeah.
Very less, right?
Yeah.
Most of the things will be, as you said, yes, they all are available on. And when I say available, it's something like, let's say if you want to use tree, the tree data set is already available, tree set, right? You don't have to code for node, right? Just like this is the kind of structure you might have studied in your college, like something like this: node, like class, node, root, something like that, or struct, node, root, something like this you might have studied in your college. I'm not teaching right now, I'm just giving you some knowledge. Such kind of things you might have studied. Obviously this and this are very contradicting. You are not using this at all in industry. Even if you're not using in industry, they will ask you this thing to code. And when I say industry, everyone, starting from Misho kind of on a company, which is startup, a small scale startup, I can say, little bit larger startups like Swiggy, to Flipkart, to Microsoft, to Amazon, and to Google, or to Facebook, sorry, Meta now. Everyone for SDE roles, which is SDE means software development engineer, SDE 1, 2, 3, 4. 4 is generally a lead level engineer. Even for EM, engineering manager, or and for architect level role. So any sort of EM related, sorry, engineering related role, SDE related role, even for UI and tester, software development engineer, software development tester, UI engineer, they ask this data structures, at least in one round. So obviously you will feel like why it is necessary, even though everything is there on internet. Any guesses why it is necessary? Well, you might have thought, you might have studied, you might have Googled it as well. So anyone who might have done it, or anyone, just thoughts, any thoughts from your side?
Like data is like the foundation of anything, right? Whatever we build is data. Like if you go to a library, if the books are not organized, it will difficult be for you to search for the book which you want to look at or which you want to get. So if they are organized in certain way, it will become easy for you to retrieve the book. In the same way, for suppose if there is a web page and you will go from one page to another page, and there will be we will be opening a lot of pages, so they have to keep track of the pages in which you are retrieving, right? So that
Yes.
when you go back, you will have to go to the next before page which you have opened. Like, based on the purpose, you have to know which data structure you have to use, so that maybe once those data is stored in the way they should be, you can use an algorithm for that particular data structure. So it is
Perfect.
very important. We have to know the purpose of that data. Based on that, we have to implement the algorithm for that data. That
Exactly.
is my understanding.
Exactly. You are spot on. So what Rohit also said, I think Rohit said last. I don't know if I'm wrong. Sorry for that, but yeah. So I
No,
think
it was
Rohit,
not right. Sorry.
who said that then? The last question, last answer, not a no, but the last answer.
I think it was Shreyas.
Shreyas. Okay. So sorry for that. So what Shreyas says is also correct. Generally, everything is available on the internet. And what Anu said is also correct. What if we want to build something from scratch and such kind of things is not available? That's second thing. Third thing, what Anu said is also correct. You should know at least the usage so that you can tweak the requirement or you can change the existing code as per your requirement. So in that direction only, we'll take up this session with few introductions part and few questions related part, that see this kind of questions they're asking and what they're judging based upon that. And that's where we'll understand the importance of data structures in each and every field of uh, software development. Okay, so generally question comes that, do I need to know DSA if I'm a UI or JavaScript engineer? Yes, you need to know. Why? We'll cover it up. Sometimes question comes like this as well, like someone said he wants to go for mathematics if it is given, because probably Safin's what we can say, I won't say expertise, but his inclination is towards maths, physics, and thereby along with the computer science. Then how they both will be combined together? Such kind of stream will be around data science and AI/ML algorithm. And he'll also say that, do I need to know DSA? Probably in interview, they may not be asking for to a data scientist, but down the line when you're working, as Anu said, everything at the end is data. How you are processing it, retrieving it, you need some knowledge on processing of that, and that's where DSA will be required. We'll see with few set of questions and few set of things that how it is being used, even for a tester. Now, before starting off, formally some session kind of a thing, it's not formal session, it's just still introduction. What is data structure? Not going further into waiting, something what Anu suggested, that data structure is something to store for your data, something like, even if you're storing like variable a, now that variable you might be defining something like integer a, character a, long a, or in Java or Python you might be doing something like this, list integer a, correct, or any kind of syntax. At the end, what you are storing some data into your variable a with the name of a, and you would be storing that, correct. Even if you are creating a class and you're creating an object, something like student is a class, student stu, so that's stu is your data, right, object which is pointing to some sort of data, where student name is 1 2 3, anything is there, right? So anything which stores data is kind of a data structure. That can be in memory, obviously, because if it is not in memory, then generally we think of it as in a DB. But at the end, DB also would be storing somewhere, right? That is also a data structure. We'll see what kind of data structures are there in market and where they are being useful. So if we see, a data structure is way of organizing data. As I showed in previous slide, it can be either a object, it can be either a array, it can be either a list, it can be either a variable. But how you are storing it, how you are effectively using it. And when I say effectively, with the terms of space and time complexity, both. Now you might be thinking, I don't know anything about space and time complexity, and Dhaval has started on that. We'll cover all that parts from the scratch. Right now, it's just an introduction where I'll be speaking those terms, but because it is necessary to give an introduction about that, and then we'll start from the scratch that, okay, what is space-time complexity? What is time complexity? Where it is useful? Why it is useful? All the things we'll cover it up. But right now, just understand that what is space and time complexity from the introduction part is something like that how much memory you are utilizing. You might have seen your computer or your laptop is getting stuck sometime. Like Microsoft, what we can say, OS had a typical blue screen when it got stuck and restarts. Right? Why? Because it is having a less memory. You might be seeing your phone getting hanged. You might be seeing your laptop is getting hanged. Why? Because it has a less memory. That is means it has a less space. And why it happens? Because you are overutilizing it. Or you have some process running which is utilizing your time and space of your processor. Now, in order to build a software from the scratch, you have to think about how it will be efficient such that it will utilize the least space and least time complexity possible. What do I mean with that? I give a very simple example. Okay, let's say you want to sort some data. You might remember, anyone you remember bubble sort? Does anyone remember bubble sort? Just anything about that? No, no worries. Let's say some process, I'm just giving it is an example. Let's say you want to sort some data like this. Okay, now what you can do is, from your brain's perspective, you know that 1 comes here and 8, 9, 10 comes late. But from the computer's perspective, he don't know, because he cannot visualize the whole data together as we are visualizing from the eye. So what it will do, it will try to find it out the appropriate place for 2. Then it will try to find it out the appropriate place for 1. So what it will do, it will search everywhere and say where 2 can fit. Okay, somewhere down the line he fitted over here. Then it will search everywhere and say where 1 can fit, and he kept 1 over here. Then 8 he'll take and search where 8 can be fitted. Then he'll put over here 8. Let's say 0 is here. Then he'll search entire space and find it out where 0 can be fitted, and 0 is fitted over here. It takes next 10 and search that where 10 can be fitted, and he kept 10 over here. And at the end, your data is sorted. But if you see how much time it took, one variable moved around the whole space. That means whole array. Wherever the places can be there, it moved everywhere and find it out, okay, what is my exact place? And he kept it over here. So that means each and every number will have to compare how many times with each other. 2 compares with 1, 2 compares with 8, 2 compares with 0, 2 compares with 10, and he finds out its appropriate place. 1 compares with each and every one. So total how many comparisons will happen? Let's say there are n numbers, then n multiplied by n comparisons will happen in a shortest way. Now assume that your 1 comparison takes 0.1 second. Then your n comparison takes what? 0.n seconds. Now what n square will take? In a simplistic example, let's say your n is 10, then 0.10 in the sense it will take 1 second, right? Or let's say if it is 100, it will take 10 seconds. So totally to sort this data with n equals to 100 numbers, your total seconds in roughly, you can consider that 10 multiplied by 10, which is 100 seconds. Now, is it a right algorithm? No, you can do still lesser than that. Just think that you have 100 data on your UI on a table, and on that you click on sort, and it takes 100 seconds to sort everything. Is it a right to wait for 100 seconds to sort data? No, right? Then what is the right way to do that? So that right way is what we need to understand. And that only will give you understanding of how you can utilize your space and time exactly such that your code is best. Either it's a UI or it's a backend or it's Databricks job. So when I say Databricks job, the Databricks jobs can be used for data science, data processing, so many things. Okay, so anywhere, whatever you do, you have to understand this kind of things such that your time and space utilization is least. You might think that, do I need this? I'll explain you where you need this. Okay, and then we'll move further later on point of time. One simple example I have given you is with the sort, but later also I'll keep on explaining this space and time complexity in general with a backends perspective, with a data structures perspective, and then we'll optimize it. We'll learn how to optimize it, and then we'll move forward with the next sessions. In the next sessions, all such kind of things will be covered. Next thing about the data structure, probably just a simple thing, types of data structure. Not sure why the image have not come. Just a minute, huh? Okay, so what I was covering over here is type of data structures. What type of data structures generally you see? They are kind of this primitive data structures, which is like integer, float. You might remember from college days, long, all that things. If not, in sessions we'll cover those as well. Some non-primitive data structures, linear, non-linear, static, dynamic, tree, graph, array, linked list, stack, queue, and all that kind of things. Generally, we don't want to worry about this thing. What is the type of this? We just want to know what is array, linked list, stack, queue, tree, and graph, and where it is being useful. Generally, we are worrying with that only. Correct. So with that, we'll see exactly what and where everything is being used, like usage of data structure. Simply array. Anyone wants to try what arrays are useful for and what arrays will be used in future or in our sessions in future in this sense. In a simplistic way, array can be used for sorting, which I simply took just now an example. A normal example is quick sort. Why I have taken example of quick sort only and not something else? Just anyone wants to take a try on that? I'm not going to teach what quick sort is. I'm just asking you why quick sort I have chosen.
Space-time complexity.
From the mathematical perspective, quick sort and merge sort, they both are same. But still quick sort I have taken. Why? Because anyone who knows computer language, in that you have something like this. Let's say you have array, then you do like array a dot sort. You might be doing that, right? Or sort with function descending or something like that, you might be doing it as well. In JavaScript or in backend language also, you might be doing that. Anyone have done it? Or anyone remember doing this thing? So you have predefined function sort. which Reyes was mentioning, that you have everything built up. Still, they are asking quick sort. The reason I kept quick sort only is because your compiler uses quick sort when you use a method called sort. So when you use inbuilt sorting mechanism, your compiler uses quick sort. That's why I've just illustrated the array can be used for sorting purpose. One of the example is quick sort. Now, just a hypothetical question. Do you use array furthermore? Just another example was merge sort, but why I've chosen, I'll take it up later. Anyone remember this kind of thing? No, for sure. But everyone would be using this. Anyone who is using Excel, anyone who is using SQL, anyone who is using any platform, your sorting will be used like this only. Your data is somewhere in different tables, different column in SQL or Excel. And when you are retrieving the data, you are sorting them based upon something. In a Excel, in SQL, you might be doing order by, or in Excel also you might be doing like selecting all the tables and then sort it by column A and column B, something like that you would be doing. In memory, it would be doing some pre-processing, something like this. It fetches all the data, puts it into some temporary table, and based upon the logic that you have given or written, it will be sorting all the data and then giving you the output, right? So yes, sorting is being useful. Then still you should have a question, why do I need to know sorting? Am I correct? Why in interview you need to know quick sort? Is that question you have? That's what I'm asking. Otherwise, we'll move further. But why this question should be there is because when you start learning, you should know why you are learning that. Otherwise, you will not get that interest. And then at the end, when with a step by step, when we build up something at the end, you'll feel like, oh, it's been built up, but because it was not much interested, you might have not given much attention to it. So my suggestion is that start asking questions to anything that comes into your mind. Why? It can be in day-to-day life as well. Why? And also with education as well. I'll give a simple example. Everything is built up. Still, have you seen this kind of experience that you are creating a table and you're giving this data with a sorting functionality? Yes, you all might have used it. This sorting happens in UI, correct? And when a full stack developer is creating UI, sometimes, because I have done that thing, that's why I'm telling you, generally we do not have a very simple tabular format only. Sometimes logic is much more complex when you are sorting data, when you are processing data. I won't say sorting, I'll say processing data. When you are processing data, you need to write sorting algorithm on your own. Let me give a simple example. Let's say you have to store or sort just this kind of data. Now on that, if you use dot sort mechanism, which uses quick sort, then generally it takes n log n time. What is n log n time? Don't worry about that. We'll cover it up. But in a simplistic method, if I say, what does it mean? That means for any processing, if you have n numbers, n is let's say 10 or let's say 100, you will do 100 multiplied by log n of 100 is 10, approximately 1000 operations. So when you use quick sort, operations means either you compare, add, swap, all that kind of things are operation. But what if I say that based upon this data, this kind of data, you can do this in order of n. That means if there are 10 numbers, 100 numbers, in just 100 operations, you can store it or sort it. Can you think why? Let me just redefine it. 1 1 2 1 3 2 1 1 2 3. If you see, you have just 3 types of data. So when you process your data, what you'll do, you'll keep a counter of 1 and you find it out 1 1 2. So 1 2 3 4 5. 5 are ones, and along with that you are counting 2. 1 2 3. 3 are 2, and then you sort the data something like this: 1 1 1 1 1 2 2 2, and the length of the number is 1 2 3 4 5 6 7 8 9 and 10. So 5 plus 3 8. The rest 2 threes are over here, and then you have sorted. How long, how many comparisons it took? Just you process the whole array once and you got this number, and just you can print this data sorted order. So that means only 10 operations you did. If the numbers would be 100, you will be doing 100 operations. And as I said, Quickshot would be taking 1000 operations. Point is, if you had knowledge from 1000 operation, you could write a logic which gives you only 100 operations. And when I say 1000 operations to 100 operation, it's huge optimization in terms of time and space, both. Consider that one operation is taking 0.1 second, and then calculate how many seconds you are optimizing. Got it? So even if the functionalities are given inbuilt, sort, and so many things, you may need to use them any given point of time in any day when you're working in a normal day-to-day routine as well. And that's why it's very much important to know data structures. You might be thinking, okay, such kind of things are pretty simple. What's the complex usages? We'll cover it up those as well. We'll cover up the complex usages of data structures as well, because array is the basics of everything. Then something else can be written as well on top of array, like scheduling. You may think, okay, do I have to schedule jobs? Do I have to, understand all these algorithms where arrays can be used, like shortest job first in first serve, largest job first or longest job first? All these things, do I need to? Probably yes. If you are DevOps guy, yes. If you are writing some code in which scheduler is there, yes. Do you need schedulers? Yes. In company, on day-to-day basis, we are writing schedulers to fetch some data, to process some data on given schedule time. Now, next thing is, from the UI's perspective or from the other perspective, let's say my job doesn't say that I have to do this. Do I still need to know array algorithms? That kind of things would be there into your mind, probably. Then I'll take one simple example. Let's say you are UI developer, okay? And you want to build a file uploader. What is the type of things that you'll think when you are writing the code for file uploader? Generally, you'll do drag and drop. What if the file size is very large? Very large in the sense, let's say 3 GB file size is there. Do you need to do some processing, or this 3 GB will directly get uploaded? And this is a very simple example of file uploader. Why? Because many of the projects may need such kind of file uploading. You might have seen, like in Passport also, you're uploading your PDF, your things, right? Your data and all that things, your certificates. On LinkedIn also, you're uploading your certificates. On Facebook, you're uploading some data and all that things. On day-to-day basis, we are using such kind of functionality, but in a similar way, in a day-to-day basis also, such kind of code you may have to write in your company. What sort of things will be required when you are uploading a very large file? don't think about backend's perspective, but from front end's perspective as well. Do you think this 3 GB file will be uploaded directly? No, it will not. You have to break it down into multiple chunks, which is called like different chunks in the sense parts, and then you have to upload it or you have to download it. There you have to apply a lot of logic. What is the sequencing of it? You have to sort it, you have to process it, you have to convert the chunks, you have to add the chunks. What if the chunks are coming multiple times from the storage? You have to find a logic to write it down such that you don't merge the chunks which is of two same type, right, and create the output. Got it? All such kind of things will require logic, will require understanding of data structures, algorithm, and this is a very simple example I'm giving that may require your day-to-day, may be required in your day-to-day. So my point is, yes, simple array structures, simple array sorting will be used in your day-to-day life as in a data structure. And that's why companies ask this kind of questions on array, on 2D array. And furthermore, anyone who have experience with 2D array in day-to-day life, every day we are using 2D array. Our screen on front, which you are sitting, that's 2D array. 2D array of pixels. Your mobile screen is a 2D array of pixels of some size, 1024 by 4096 or something. Am I right? Say yes or no.
Yes.
Right. Any algorithm which is given on top of that will require your logic. So here it is just a representation of 2D array, that how it is being storing the data and all that things. Right now you don't have to worry on that. Right now what you have to worry is where it is being used. Generally in the applications like chess, Sudoku, crosswords, snake ladder game, Minesweeper, and all that things. Your screen algorithms, your verbal arithmetics, parser, that you write it down, everywhere 2D array is being useful. You'll still feel like, do I still need to code 2D array? You may think like that. Let me give a simple example, and from there we'll take it up. Generally chess, Sudoku, gaming companies would be using it. So a gamer or a mobile application developer may need to understand 2D array and their concepts. Not everyone else. That's what your understanding would be right now. Right. Now here is a typical interview question that solve a retina maze problem or a warehouse solution. Let me explain that. Okay. Will not go for the solution, will not go for anything else. We'll just see how and where it is being converted from an interview question to a real world scenario. And that's where you will have an understanding that why in interview they're asking DSA, and how from DSA you can understand where it may be useful in real world. So we'll take this question in a simplistic way, just to consider it as a puzzle, and then we can move further. So the question is that you are given a 2D array in the sense just normal matrix in which there are multiple paths, like this is a path, another is a path, such kind of path. Write a solution. They will say something like this in interview, that write a solution such that you will create a path for a rat in this maze where there are multiple paths, but only one path leads to a destination. While studying in college, you might be feeling like, why I'm studying this, where it is being useful. Right now also, if I take this question, without giving you any of the knowledge, and we start array to the array, and then this kind of question comes, you will feel like, why the hell companies are asking these questions when they are not using it? Do I have to write Sudoku everywhere? No. Do I have to create a chess every day? No. Then why Flipkart is asking this question? Why Amazon is asking this question in interview? Any guesses? Anyone can take a hunch or a hint why this kind of questions will be there in interview?
So maybe I can think of one solution. So maybe let's take the case of Swiggy. They might have to find uh, the source could be the restaurant and the destination could be um, the customer's place, and maybe they know from their data where are the typical traffic. I mean, I don't think so it's about Swiggy. Maybe Google Maps
Google
can use
Maps.
properly, right?
Exactly.
And create a proper routing based on that. Could be
Exactly.
a
Exactly. So that could be one solution. But as an engineer, you may think like, मुझे तो कभी Google Maps पे काम करना ही नहीं पड़ेगा, मैं Google में नहीं जाऊंगा. Then probably you'll think, अरे यार ये useful नहीं है, छोड़ो. Such a kind of tendency we have because something which our mind feels that it's obscure, which is very difficult, it will try to run away from that. That's how our mind works. And why I'm telling you this is because when I was QA engineer and then I started working upon coding part in Oracle itself, done some projects, but I did not know data structures algorithm. When I started giving interview questions, they asked me this question, this type of questions. What I started doing is bugging up. Okay, ये रट लो, ऐसे कुछ कोड लिखोगे, ऐसे कुछ रिकर्जन लिखोगे, ऐसे कुछ फंक्शन लिखोगे और ये हो जाएगा. That's what I have started back in 2013. But does it help? No, it did not help me at all. At that time, my mind was running away because I did not know where it was being useful until I started learning everything from scratch. And where I used it, I found it out in Naiva. That is useful. So that story just I want to share with you where I found it useful. Just one correlation that will give you an insight that whatever was there in our books, in college books, data structures algorithm, or I'm going to take, that is useful. A simple example, let's say as I told you, warehouse solution criteria based problem. Probably they asked you know the solution, you coded it, okay? But if I tell you that this is a typical warehouse that you might be seeing it, what does it look like? Does it look like 2D matrix? It's type of a 3D matrix, but I'll tell you why it is a 2D matrix. When a person comes from here to here or goes from here to here, generally he fetches all the items from either the 0th rack or first rack, not from this all racks. These are just for the storage purpose. Either the multiple items of this or other. That's what I have seen. So a person who is a picker, I can say a guy who is a picker of an item, he comes around and moves into warehouse and fetches whichever item is available on the 0th or first rack. So in that way, isn't it a 2D matrix that it is your 0th row, first row, second row, third row, fourth row, and so on. And you need to find it out what items are placed anywhere. Then still you might be thinking, why do I need 2D matrix ka code? I can give directly the example कि भाई there is one picker, okay? उसको बताया गया है कि भाई warehouse में जाओ और 4th रैक में से डिटर्जेंट लेकर आओ, 5th रैक में से 4th रैक, 5th कॉलम को कुछ बोल सकते हैं, 5th कॉलम में से डिटर्जेंट लेके आओ, 5th रो और 5th रैक, और 10th आइटम जो होगी वो होगा तुम्हारा आटा, वो लेकर आओ एंड खत्म. Now, if I have to tell this guy these things, do I need to know 2D metrics or 2D metrics algorithm? Yes. Let me tell you how. Consider that you are working for Flipkart, okay, or Amazon, and in your company, your project is to create such robots. Many startups are creating such kind of writing such kind of robots. Many startups in India, like in Gurgaon, there are few robotics companies. Amazon also started their own teams for these robots, which will pick up this whole rack and bring to the table, picker table. Person will choose the item and drop it. Now, obviously, based on as you are the team member, you may have to write such algorithms कि कहाँ से क्या item fetch करना है. And where this robot is a simple machine, you may have to write algorithms which will fit in 2D metrics, because at the end your warehouse is 2D metrics in a simplistic way. Am I right? That's the first thing. Now consider that you're not writing, let's say, you're not writing for robots as well. You might be thinking you're writing for a person. Then also, daily you are getting, let's say, 15,000 orders. Okay, you have, let's say, 100 people who will go around warehouse and will pick. Do you think that you'll be able to find it out the places for all 1500? No. What will happen is that you have to efficiently ask this guy to fetch something like this. You go to first rack and pick up this 10 items from different one. Go to second rack and pick up this 15 items. Go to third rack and pick up this some items, and at the end come out of the warehouse with 100 items. Right? Efficiently, if he moves towards the warehouse, efficiently when I say from first row to second row to third row to at the end, if he's picking up all the items efficiently, just in one iteration, he can fulfill 100 orders. But if he's not efficient and you are not giving him, or if you are giving him order something like this, go to fifth row, then go to 10th, then go to fourth, then go to third. Consider that how many times he'll have to move towards the whole warehouse. He'll have to go to and from multiple times, and then your 100 orders will be fulfilled. This will take 2 to 3 hours. This will take just 1 hour, because he just have to blindly follow this order. So this order of processing, who has to create? Your code has to create. And that takes 2D algorithm, 2D metrics algorithm. Why I'm telling you is because I have worked on such kind of algorithms when I was in Flipkart. Though that project worked almost for 4 months, but for that 4 months, we have used extensive 2D metrics and their algorithms. So you might be feeling that, yes, now you may relate कि not just array, 2D metrics और ये सब algorithms भी useful होते हैं. And when you feel that yes, they are being useful, then only then you can relate to this kind of things कि where in industry they are useful and why they are asking this type of interview question. So far clear? Any questions? You can ask me and stop me anytime and just discuss anything. Nothing? What are your thoughts so far? With the session, along with the session, or anything? Are you finding relation with DS with real world scenarios where you will be using these scenarios and all, or no correlation at all?
Yeah, able to correlate.
No, just you don't have to comply with me. You can discuss anything. That okay, I feel, I don't feel. I may have not used it, but right now I feel, or you may be feeling like, yeah, such kind of things I have used in my past. Anything you can share.
Yeah, like with respect to implementation means we have used in project like to DSA or list or something like. But with respect to thought process, never thought like in warehouse it will be used like this. So thought process. So right now I may be thinking in every student whether this data structure or we can use something like that or not. So yeah.
So when we play with chess as well, the computer uses this 2D array to find optimal move to win the game like that.
Yes. Now let me tell you in which way. That's a very nice topic that you brought. That's why I just want to cover it up. Okay, Abdul, it was a very nice point. So okay, forget about this thing. I'm just finding some blank space. Okay, so I'll use this blank space for some discussion. What happens when some logic of chess or Sudoku happens? Computer, just like this rat in a maze problem, computer tries to find it out an appropriate place to put your either any one of the piece or in Sudoku some number. And that requires the same kind of algorithms of rat in a maze. Rat in a maze generally uses backtracking and recursion with 2D metrics. The same backtracking and recursion is used over here, but in a different way. So what happens is, if it finds a way, it will complete. Otherwise, it will try a different piece, or it will try a different route, or it try for a different number. In a Sudoku, piece with chess, route with a warehouse algorithm. That is called backtracking. So yes, same algorithms are being used, or a similar algorithms with different implementations are being used in chess and Sudoku and warehouse problems. Now that's why they ask you Sudoku question just to understand, do you understand backtracking? Do you understand recursion? Because in future, in a product-based company, you may have to write your own algorithm. As I said, I have worked with similar kind of algorithm in Flipkart. Obviously, in that algorithm, there was just not few constraints of where the items are, but many constraints like detergent and atta you cannot put together. Ice creams and such kind of vegetables or such kind of things are at a different rack and all that things. And finally, you have to find it out an optimal route. Such kind of code was there or algorithm was there, but that's a separate thing. But my point was, crux of that algorithm was such kind of things only. And as I said, in industry, generally in product-based companies, that is extensively used. And that's why they ask such kind of questions. Now, this is another question like rotate a matrix. This is another interview question, okay? Simple interview question, rotate a matrix. People will feel like, hey, it can be done very easily in mathematics, like, right? It can be done very easily in a code as well if some function is written. And if such function is not written, probably you'll have to write it down. Is it useful in industry? Sort of logic you may have to write it down when you are rotating, but it is useful in industry. Yes, it is very much useful in industry. Do you use it in your day-to-day basis? Yes, when you rotate your phone, right or wrong? Rotate your phone, the whole pixels which are created as 2D metrics, they are just converting from here to here. Like whatever your row is, first row's pixels are, that will become your first column's pixel. Obviously, in industry or in interview, they will ask you with a simple square matrix, but in industry, you'll use non-square matrices as well, M cross N, and all those things. Yes, for a front-end developer or for mobile developer, those algorithms are written. But what about the people who have written those algorithms first time? Being a front-end developer, you have to use these algorithms. What if you want to change something in that algorithm such that You are not converting row into column blindly, but you are taking care of pixel and picture quality as per your game or as per your application. Then do you need to understand this algorithm of rotation? Yes, you need to understand, because in an existing code of your kernel, in an existing code of your I won't say kernel, sorry, what you can say, some tool that you have used or some extension that you have used in which screen rotation is directly a function. If you have to go inside that and you have to change it, you need to understand an existing algorithm. On top of that, you will understand how this function is implemented, and then you'll update your logic of pixel or your color combinations or anything else, right? So my point is, it's very much necessary to understand, because such kind of industry questions will be anywhere. So probably some industry there where such kind of requirements will be there, they will ask this kind of questions. Rotate. Some industry where warehouse related teams are there, they may ask you 2D metrics with backtracking and all that kind of questions. So that's why for each and every team, for each and every company, the interview questions will be different. You maybe feel like, okay, if I'm giving interview in Azure team, or for Microsoft Azure team, or for Microsoft something else, or for Amazon A team and Amazon's B team, the interview questions for data structures will be almost similar. No, they will not be similar. They will be based upon the team's usages only, where they will try to find it out, will you be able to work on such kind of DS problems in future if they arise? And same way for system design, and in the same way for low level coding and high level coding as well. So quickly going through this algorithm, how everything is happening. And as I said, in screen rotations, you can be using, in machine learning, you can be using, where you're understanding your data, which is kept into 2D metrics, where you have linear correlation, you have positive correlation, you have no correlation at all. So this understanding from where you'll build up, where your data is stored in 2D metrics in your machine learning algorithm, and your machine learning algorithm will find it out a relation based upon the data, the way it is stored into 2D metrics. It's a very typical use in data science and machine learning. So my point is, the base is DSA, and that's why they ask you these questions. So far clear?
Yeah.
Anyone else has some question, any doubt, anything? You can comment, you can raise a question right now.
Can you repeat that backtracking thing? I didn't get that.
So backtracking in the sense, what happens? Well, I'm not explaining right now backtracking and all that things. So what happens is, let's say one route, one solution doesn't work, right? Then it will try to find it out a different route or a different type of solution. That means in a chase, your coding algorithm, what it will try? It will first try to put a piece in an empty space and say, is it possible? No, it is killing. Then it will go back and it will put piece in a different position. Either it can be piece, it can be rook, it can be bishop, it can be queen, and it will try all possibilities. And when I say it will try all the possibilities, what it happens generally is that if one possibility doesn't happen, then it will try a different possibility. So when you try something, come back and try different possibility, that kind of algorithm is called backtrack. So such kind of logic generally you use in all gaming industry to find it out which is best. And the same backtracking you'll be using in machine learning and data science. So crux of that is recursion and all that things. So that's why, so right now my session over here that I'm taking is just to find it out, or just to explain you that what is the correlation with data structures and in industry in day-to-day life, such that you'll find the necessity of DSA for UI engineers, for machine learning, for backend engineers, everyone. And then if you have, obviously, if you get an interest, then only then you'll study perfectly, because you should know the need. And then you can excel into the interview as well, because in interview right now, they are asking such kind of questions. So my thought process is that you should not just know coding from the front end back end, just go front end and back end blindly, which let's say polymorphism कैसे use करे या for loop or while loop का कैसे use करे, but how efficiently, that also, because that thing is useful in interview and in industry day-to-day life as well. So with the usage of DSA, you will be a better developer, better coder. It can be ML, it can be UI, it can be backend. And that's what right now I'm taking.
And for this sorting, I guess permutation and combination knowledge is also required.
Not for sorting, but for machine learning, permutation and combination logic will be there for sure. But for rest of the DSA, mathematics is not much used.
Because you told about that rotation. So
rotation we are not doing mathematically. We are doing very logically. See, each row is becoming each column. Or you are using such kind of this algorithm. Right. So my point is, when we'll teach, I'll explain you how to build up a solution from the scratch. Okay. So my point is not exactly mathematics, but the logic is important, right? Now, some of the nonlinear data structure, tree, graph, and quickly we'll cover where it is being used and all that things. Okay. And when I say quickly, why? Because some of the things we have discussed so far, something like when someone say when a Swiggy guy or someone wants to move from one location to another location, he'll use Google Maps. And how Google Maps is storing their data into their backend is via graph. So my half of the knowledge, half of the logic was there just to give you an explanation that where graphs are being used, where trees are being used. Someone also said where trees are being used. Who said that? She might not be knowing when she used word of library and how in the library trees are being used. Because when you sort all the data, you use indexing to find it out at which location which books are there based upon index. You are using trees. And that's why generally, as I said, in industry, such kind of questions will be there. We'll quickly see through all the types of things. What kind of trees are there? What kind of graphs are there? In depth, we'll take it up later. But generally, when you're storing some data, right, you're storing in such kind of tree way. And where such kind of tree way the data you are storing, generally B plus tree in college you might have studied. So I'm not taking much time, but in a simplistic way, all of those data which are storing into SQL, which are storing into Excel, they are using such kind of B tree and B plus tree in MyDB, MongoDB, MySQL, and everywhere. And in that way only indexing is working. And that's why even if your DB size is in trillion rows, such kind of 100 GB, 1 TB, your data which you are fetching based upon index is very much faster. So when you have to work upon some new database, as I said, let's say you are working on AWS team who is writing an algorithm for Cosmos DB, or who are appending a new algorithm for Cosmos DB. Right? Cosmos DB belongs to Azure. Some other DB, let's say DynamoDB, belongs to Amazon. So if you are in that team and you are changing the existing algorithm, you may require this logic of B tree, B plus tree and everywhere. Not may, for sure you will require. When you are storing dictionary, how in dictionary everything is stored, or in indexing it is stored with a trie data structure. I'm not giving an explanation what is trie data structure, but just an example. Let's say when you're storing some data of deal, dear, do, or something, it is stored something like that to optimize a space as well. Like D or do, and D is used again to store dear, DEA, and DEA is used multiple times to store dear and deal. And in that way only, your any words are being stored into this whole world. What do you think your browser would be using it? In your browser, when you just click one, what we can say, domain, say sbi.co, how do you think it finds its in IP address very quickly? It stores the data into trie, so that otherwise think about it, you have millions or billions of domains. Do you think even when you are storing into DB, it takes just fraction of second to fetch such kind of IP address and load you the data? No, it stores the data. It shows you that they have showed there are millions of what we can say domain, but at the end it might be storing just some 10,000s of nodes or data, such that it can be very optimal. And if I give an example, it can be something like this. Root, let's say Alibaba, so A L I, and over here it's IP alibaba.com. Just an example. And A M A Z in a such a way amazon.com, and it's IP. Now when you have to search, let's say amaze or some other, let's say amazing, their IP would be just over here. So the storage you are utilizing of this many characters, right? In the same way, each word in dictionary is also stored like that. That's why, as I say, when you are a network engineer, or when you are,
Sir,
yes,
hello.
yes, yeah, someone is asking question.
When the lecture is over?
12.
Okay, sir. Because of my exam.
Yeah, you can go ahead with this recording session. You can go through these sessions as well if you have some urgent. Okay.
Okay, sir.
Sure. So some examples of mathematics and arithmetic stuff. How generally parser uses your expression tree to compute the mathematical terms. So these are just few industry examples. Now a simple example of a UI engineer.
Sir, this one question: how can we know that the data is non-linear? Like, how can we recognize that it's linear or not?
I'll cover that part when I start data structures. Okay, so it's just an introduction, but when we start the data structures in full-fledged, I'll explain you what are data structures of linear, non-linear types, and where it is being used and all that things. And each and every data structures with their interview questions and all such kind of things. Okay. Now, generally from the UI's perspective, someone who might have worked with a code, you might be working with JSON. Anyone who has worked on JSON?
Yeah.
So generally a JSON has such kind of structure, right? Key, then value, then key and value. A simple, similar kind of algorithm. When you have to parse this data, you have to write some code, and this JSON is different for each and every APIs, each and every signature of your APIs, right? You have to parse your data. Just see over here that your data has a children node, it again has a children node, it again has a children node, and so on, right? When you have to parse this data, you have to write some complex logic, correct? And when it is having the children of children until some depth, you may have to use recursion, right? So my point is, it's not just like you should know recursion, it will be used in your day-to-day life as well. And when I say recursion, recursion will be used in tree, recursion will be used in 2D array. And that's why to a UI engineer as well, companies ask this question in interview. They just want to see if you can understand the recursion concept in tree very simply, or in try very simply, or in 2D matrix very simply, you can implement the same recursion algorithm into complex JSON structure also as an UI engineer to parse this data, to parse this XML, or to parse this JSON. And that's why for UI engineers also, they ask this kind of questions. So in today's session, my idea was just to give you a logic, or just to give you an idea that why they are asking DSA question, and also where it is being useful in industry in day-to-day life. As I said, recursion is useful over here, or in warehouse it is used as 2D metrics, and screen it is used as 2D metrics. In dictionary indexing it is used as try, and so on. So my idea was just to give you an insight that where it is being used. And just this was an example of graph, because we have discussed about graph, I'm just taking a little bit quickly, just like how a graph is used to store the data for a maps, and in such a way only we'll have to find it out some map accordingly. There are some startups who are working on maps like Map My India and some other, which are using their own algorithms to find it out routes, which are more efficient than Google as well. So if you are working with some startup, you may have to write your own algorithms on top of that. And do you think that it's just a backend algorithms? No, it will be front end as well. How in front end this graph will be shown? This graph will be shown, all this complex graph will be shown how? With some UI technology, with some JSON technology. So in JSON as well, you will have to code all these things. Say it a simple graph, say it a simple logical things or anything, right? Let's say someone is interested in data science, machine learning algorithm. He might think, do I need graph? Do I need dynamic programming? So as I say, the UI engineer also will have to use such kind of JSON to show the data over here, to render the data over here. And as I was telling, like some interview questions of dynamic programming is like longest common subsequence. Do a data science engineer need to know about this? Yes. This is one simple example. I'm just taking. This is a paper, industry paper of IEEE, and some genome sequencing was used for some research on data science to prove something, okay, and biometrics. That was a combination of a data science and biometrics research paper. Now the genome sequencing is using to find it out some relevant scores based upon the species and all that things. Now if I just say that this was a similar way of genome sequencing or finding the closest common subsequence between the numbers, then you'll probably not understand. But see, if you see over here, the longest common subsequence is, try to find it out the common characters between two strings. That is your typical dynamic programming LCS question. You might have studied in your college, and in interview also they are asking this question. Why? Because not just as a data scientist, but also as a backend engineer, you may have to use this. Where? Here. Because the concept of matching, string matching algorithms, now it can be regex, in your day-to-day life in UI backend, or it can be data science with genome or some other string pattern matching algorithms that you are utilizing. Everywhere the crux is LCS. So that's why even if you are data scientist, they may ask you this question in interview. Because if you know the crux, if you know the basics, like how 2 + 2 4 happens, then you can do 2 multiply by 2 or 2 factorial as well. And that's why the DSA is your 2 + 2 or 2 multiply by 2. And the industry is how you utilize 2 factorial. And that's why they ask in interview questions how 2 + 2 happens or how 2 × 2 happens. And that is this, your crux of DSA, dynamic programming, tree, try, 2D matrix, and rest of the things. Make sense? So with this, we'll rest our session today.